Hello dear students, we are going to solve some numerical problems related to DC electric circuits. At first let us review the related formulas. From Ohm's law, V is equal to IR, where R is resistance and I is the current flowing due to potential difference V. Also R is equal to rho L upon A, where rho is resistivity, L is length and A is cross section area. Reciprocal of resistivity is called conductivity. The unit of resistivity is ohm meter and the unit of resistivity is per ohm per meter. Resultant resistance in series is given by the direct sum of all resistances, whereas the resultant resistance in parallel is given by 1 upon R. P is equal to 1 upon R1 plus 1 upon R2 plus dot 1 upon Rn, where Rp is the resultant resistance in parallel. Electric field intensity is related to the resistivity and current density J by this relation. E is equal to J into rho, where J is current per unit cross section called current density. Electric current is related with drift velocity of electron according to the relation I is equal to N E A into Vd, where N is free electron concentration, that is number of free electrons per unit volume. E is electronic charge, A is cross section area. Next, in open circuit, terminal potential difference of a cell is equal to its EMF E. But in closed circuit, terminal PD of cell becomes E minus I into R, where I is the current flowing in external resistance R and in small r is internal resistance of cell. It is also equal to I into R, where I is E upon R plus R into R. Power, electrical power P is given by I square into R, which is also equal to V square upon R, which is the product of current into voltage, and therefore electrical work done will be equal to I square R into T. Now question number 1. Question is, a copper wire of diameter 1.02 millimeter carries a current of 1.67 ampere. If the free electron density in copper is 8.5 into 10 to power 28 per meter cube, find current density and drift velocity of electrons. So, solution to question 1. Given in copper wire, radius is diameter upon 2 means 0.51 millimeter, which is 0.51 into 10 to minus 3 meter. Resistivity and current are given. Current is 1.67 ampere and free electron concentration small n is 8.5 into 10 to power 28 per meter cube. We have to find the current density. And drift velocity. Now, surface current density J is given by current per unit cross section area, so it will be I upon pi r square. I is given to be 1.67 ampere upon pi into 0.51 into 10 to minus 3 square, which gives a current density as 2.04 into 10 to power minus 6 ampere per meter square. Now second part, I is equal to NEA into VD, or VD will be equal to I upon A into N into E. I upon A is J, so it can be written as J upon N into E. Values are known, therefore VD will be equal to J upon N. J is 2.04 into 10 to minus 6. N is 8.5 into 10 to power 28, and E is electronic charge 1.6 into 10 to minus 19, which gives VD as 1.5 into 10 to minus 4 meter per second. Next, question number 2. The question is, resistance of a copper wire of length 1 meter and diameter 1 millimeter is 2.2 ohm. Find resistivity and conductivity. Solution to question 2 given for copper wire. Length is 1 meter, diameter is 1 millimeter, means radius is 0.5 millimeter, which is 0.5 into 10 to minus 3 meter. Resistance of wire is 2.2 ohm. We have to find the resistivity and conductivity. Now, R is equal to rho L upon A. Therefore, rho will be equal to R A upon L. Rho will be equal to R into pi R square upon L. Values are known. R is 2.2 ohm into pi R, small r is 0.5 into 10 to minus 3, its square, upon length is 1 meter. So we get rho as 1.728 into 10 to power minus 6 ohm meter. Now, reciprocal of resistivity is called conductivity. It will be 1 upon rho, 1 upon 1.728 into 10 to power minus 6, which will give 5.79 into 10 to power 5 per ohm per meter. Next, question number 3. The question is, a copper wire of diameter 1.22 millimeter and cross section area 8.2 into 10 to minus 7 meter square has resistivity 1.72 into 10 to minus 8 ohm meter. It carries a current of 1.67 ampere. find the magnitude of electric field in wire and potential difference between two ends of wire 50 cm apart. So, solution to question 3 given. For copper wire, diameter is 1.22 millimeter, therefore radius will be 0.61 millimeter, 0.61 into 10 to minus 3 meter. Resistivity is 1.72 into 10 to minus 8 ohm meter. Cross section area is 8.2 into 10 to minus 7 meter square. It carries a current of 1.67 ampere. We have to find the magnitude of electric field and potential difference across L is equal to 50 cm is 0.5 meter. Length of wire. This is magnitude of electric field intensity. Now, first we know electric field intensity is J into rho, where J is I upon A. So it becomes I upon A into rho. Therefore, E will be equal to I is 1.67, rho is 1.72 into 10 to minus 8, and cross section is 8.2 into 10 to minus 7, which gives E as 3.5 into 10 to minus 2 volt per meter. Second part, E is also known as potential gradient. It will be V by L. Therefore, V will be equal to E into L. Therefore, V will be equal to E is 3.5 into 10 to minus 2 and L is 0.5. So, we get V 1.75 volt. Next question number 4. The question is, a cell of EMF 18 volt and internal resistance 3 ohm has terminal potential difference of 15 volt when connected with a wire. Find the resistance of wire. Solution to question 4 here given. This is a cell of EMF E 18 volt and internal resistance 3 ohm. This is connected with a wire of resistance R, so that the terminal PD between two terminals of battery is VAB is equal to 15 volt. So we have to find the value of R. In closed circuit solution, in closed circuit, VAB is equal to I into R, where I is E upon R plus internal resistance into R. Now VAB is given to be 15 volt, E is 18 volt, R is unknown and small r is 3 ohm into capital R. On solving, it gives capital R as 15 ohm, which is the resistance of wire. Next question number 5. The question is, a battery of EMF 1.5 volt has terminal potential difference of 1.25 volt when a resistance of 25 ohm is joined to it. Find the current flowing, internal resistance and new terminal PD when 25 ohm is replaced by 10 ohm. Solution to question 5. Given E is equal to 1.5 volt, VAB is equal to 1.5 volt with external resistance R is equal to 25 ohms. We have to find current, internal resistance and new terminal PD VAB dash when R is replaced with R dash is equal to 10 ohm resistance. Now solution. First part, VAB is equal to I into R. So I will be equal to VAB upon R. VAB is 1.25 and R is 25. So current I comes to be 0.05 ampere. Second part, also I is equal to E upon R plus R, that is 0.05 is equal to 1.5 upon 25 plus small r, which gives small r as 5 ohms. Third part, when R is replaced with R dash, then VAB dash will be equal to E upon R dash plus R into R dash, which gives 1.5 upon 10 plus 5 into 10, which gives 1 volt. So the new terminal PD will be 1 volt. Next question number 6. The question is, in the given figure, when switch is open, the voltmeter reads 3.08 volt. When switch is closed, then voltmeter reading drops to 2.97 volt and the emitter reads 1.67 and the emitter reads 1.65 ampere. Find EMF, internal resistance and value of R. Here given in this circuit, in open circuit VAB open is equal to 3.08 volt, and when switch is closed, VAB in closed circuit becomes 2.97 volt, and emitter reads I is equal to 1.65 ampere when switch is closed. Then we have to find EMF E, internal resistance R, and value of external resistance R. Solution to question 6. First part, we know terminal PD in open circuit is equal to EMF of cell. So, VAB in open circuit will be equal to EMF. So, EMF will be equal to 3.08 volt. Second part, with switch closed, VAB closed will be equal to E minus I into R. VAB closed is given to be 2.97 is equal to E is 3.08 minus I is 1.65 into R. So, we get R as 0.067 ohms. Third part, also in closed circuit VAB closed will be equal to I into R. 2.97 is equal to 1.65 into R, which gives capital R as 2.97 divided by 1.65, that is 1.8 ohms. Next, question number 7. The question is, in the given figure, current through 3 ohm is 0.8 ampere. Find the potential drop in 4 ohm resistor. Means, in this diagram, current in 3 ohm resistor, suppose this is I1, is given to be 0.8 ampere. So, solution to question 7, given I1 is equal to 0.8 ampere, this current, we have to find VPC is what? Means potential difference across 4 ohm resistor. In parallel, voltage is same, therefore VAB will be equal to I1 R1 is equal to I2 R2, means the potential difference between points A and B is same as I1 into R1 and I2 into R2. This is R2. So I2 will be equal to I1 R1 upon R1 R2, values are known, 0.8 into R1 is 3 upon R2 is 6. This gives 0.4 ampere. Therefore, I will be equal to I1 plus I2. I will be equal to I1 plus I2. This is 0.8 plus 0.4, which is 1.2 ampere. Therefore, required potential difference between B and C will be equal to I into R3. This current into this resistance, 1.2 into 4, which is 4.8 volt. Next question number 8. The question is, consider the figure below, means this figure. The current through 6 ohm resistor is 4 ampere. Find the currents in 25 ohm and 20 ohm resistors. Means I1 is given to be 4 ampere. We have to find I3 and I4. Solution to question 8. Given I1 is equal to 4 ampere, we have to find I3, current in 25 ohm, and I4, current in 20 ohm resistors. Now, in parallel, B will be equal to B between A and B will be equal to I1 R1 is equal to I2 into R2. This gives I2 as I1 R1 upon R2. I1 is 4, R1 is 6, and R2 is 8. Means this is 3 amperes. Therefore, I3 will be equal to I1 plus I2. I3 will be equal to I1 plus I2, means 4 plus 3 is equal to 7 ampere. Now, in upper branch, resultant resistance will be equal to resultant between A and B plus R3. So, the resultant resistance between points A and B will be 1 upon RAB is equal to 1 upon R1 plus 1 upon R2. That is 1 upon RAB is equal to 1 upon R1 plus 1 upon R2 equal to 1 upon 6 plus 1 upon 8, which gives 7 upon 24. Therefore, RAB will be equal to 24 upon 7, which is 3.43 ohm. Thus, the resultant of these two parallel resistors is 3.43 ohms. Now, this combination is in series with R3. Therefore, resultant resistance between A and B via this path is, suppose that is RAB is equal to RAB plus R3, which is 3.43 plus 25, that is 28.43 ohms. Now, this upper branch and lower branch being parallel, potential difference between points A and B will be same, that is VAC will be equal to I3, because I1 plus I2 is I3 into RABC. This current I3 into this resistance is equal to I4 into R4. I4 into R4, which gives I4 as I3 into RABC upon R4. I3 is 7 ampere, RABC is 28.43, R4 is 20, therefore I4 is 9.95 ampere. Next question number 9. The question is, what is the potential difference across 100 ohm resistance in the following figure? The circuit diagram is this one. Here this is 100 ohm resistance and 50 ohm resistance, both are in parallel, and a series resistance of 500 volt, series resistance of 500 ohm is connected to them, along with battery of 12 volt. We have to find the potential difference across 100 ohm, means solution to question 9. Given suppose this is R1, this is R2, and this is R3. In the given diagram, we have to find VAB, that is potential difference across 100 ohm. Now R1 and R2 are in parallel, therefore 1 upon RAB will be equal to 1 upon R1 plus 1 upon R2, 1 upon 100 plus 1 upon 50, 100 is LCM, 1 plus 2 means 3 upon 100, which gives RAB as 100 upon 3, 33.33 ohms, means resultant of these two resistances is 33.33 ohms. Now this RAB is in series with the R3, therefore current I will be equal to V upon RAB plus R3, 12 upon RAB is 33.33, R3 is 500, 12 upon 500, 33.33, which gives 2.25 into 10 to minus 2 ampere, means this current I is 2.25 into 10 to minus 2 ampere. Now in this parallel resistance also VAB will be equal to I1 R1 is equal to I2 R2, which gives I1 into 100 is equal to I2 into 50. That is I2 is equal to 2 I1, but I is equal to I1 plus I2. This I is equal to I1 plus I2, which is I1 plus I2 is 2I1, 2I1. So I will be equal to 3I1, which gives I1 as I upon 3. I upon 3. I1 is equal to, I is 2.25 into 10 to minus 2 upon 3, which is 0.75 into 10 to minus 2 ampere. Means this current is 0.75 into 10 to minus 2 ampere. Therefore, VAB will be equal to I1 into R1. I1 is 0.75 into 10 to minus 2 into R1 is 100. So, it gives 0.75 volts. So, the potential difference across 100 ohm will be 0.75 volt. Same potential difference will be across 50 ohm as well. Next question number 10. The question is, in the given diagram, a battery of EMF 24 volt and internal resistance R is connected to 3 ohm, 6 ohm and 8 ohm resistors. If the current in 3 ohm resistor is 0.8 ampere, find the current in 6 ohm and internal resistance of cell. So, in this diagram, this is a battery of EMF 24 volt and unknown resistance, internal resistance, unknown internal resistance R. 3 ohm and 6 ohm resistors are in parallel, whereas 8 ohm is in series. We have to find I2 and R. Given I1 is equal to 0.8 ampere, we have to find I2 and we have to find internal resistance of cell. Resultant of or resultant of parallel resistors, resultant of R1 and R2 means 3 ohm and 6 ohm is 1 upon RAB is given by 1 upon RAB is equal to 1 upon 3 plus 1 upon 6, LCM is 6, 2 plus 1 means 1 by 2. So, RAB is equal to 2 ohm. Now, this 2 ohm is in series with 8 ohm. Also, in parallel, potential difference is same. Therefore, I1 into 3 will be equal to I2 into 6, which gives I2 as I1 into 3 upon 6. I1 is given to be 0.8 into 3 upon 6 means 0.4 ampere. So, I2 is 0.4 I2 is 0.6 ampere. Therefore, I will be equal to I1 plus I2, I1 plus I2, which is 0.8 plus 0.4 is equal to 1.2 ampere. Also, I is equal to E upon RAB plus 8 ohm plus internal resistance, means R between A and B plus R between B and C plus internal resistance. So, I is 1.2 is equal to 24 upon RAB is 2, RBC is 8 and internal resistance is unknown. So, we get small r as 10 ohms. Thus, I2 is 0.4 ampere and internal resistance is 10 ohms.